Here's problem 7 from the 2024 AMC 8. A 3x7 rectangle, made of 21 unit cells, is completely covered, with no overlaps, using tiles of 3 shapes: 2x2 squares, 1x4 rectangles, and 1x1 squares. What is the smallest possible number of 1x1 tiles we can use? The choices are 1, 2, 3, 4, or 5. You can pause here and solve the problem before seeing the solution. Here's the key idea. Both the 2x2 square and the 1x4 rectangle cover exactly 4 cells each. The whole board has 21 cells. So if M is the number of 1x1 tiles, then 21 minus M, the cells covered by the big tiles, must be a multiple of 4. That means M leaves a remainder of 1 when divided by 4. So M can only be 1, 5, 9, and so on. Can M equal 1? A coloring argument says no. Shade every other column, starting and ending with a shaded column. That gives 4 shaded columns, 12 cells, and 3 unshaded columns, 9 cells. Now here's the magic. Every 2x2 tile and every 1x4 tile covers exactly 2 shaded cells and 2 unshaded cells. So the big tiles are perfectly balanced. That means the 1x1 tiles alone must make up the difference. Shaded cells minus unshaded cells equals 12 minus 9, which is 3. So we need at least 3 1x1 tiles. But M must be 1 more than a multiple of 4. And the smallest such number that is at least 3 is 5. And 5 really is achievable. Here's one tiling. 3 1x4 rectangles fill the first 4 columns. 1 2x2 square sits at the top of columns 5 and 6. And the remaining 5 cells are 1x1 tiles. 4 of them land in shaded columns and 1 in an unshaded column, exactly matching our count. So the minimum number of 1x1 tiles is 5, which is choice E.